In 1900, American railroads were slaughterhouses on wheels. 1 in every 28 railroad employees was injured on the job. 1 in every 400 would not come home. Boiler explosions hurled chunks of iron weighing 16,000 pounds through roundhouses, killing a dozen men at a time. Wooden passenger cars telescoped into each other during collisions, crushing everyone inside. The industry that built America was also butchering it. Branch lines were bleeding money, and rural towns faced a grim choice: accept isolation or bet on trains that might kill them. Into this crisis rolled a machine so terrifying that engineers called it the suicide sled. Its steel prow came to a knife-edge point that safety officials predicted would slice through anything it hit, including the passengers seated behind it. Yet this machine, built in defiance of expert opinion, would operate for 4 decades across dozens of American railroads, without a single recorded passenger fatality attributed to the design everyone feared. How did the deadliest-looking train car ever built become one of the safest vehicles of its era? The year is 1903. The Wright brothers are about to fly at Kitty Hawk. But on America's railroads, nothing is taking off, except the casualties. Steam locomotives were magnificent machines, but they were vampires. A single engine required a fireman, an engineer, a conductor, and brakemen. The boiler consumed mountains of coal. The water stops alone 8 hours out of every run. For the Union Pacific main lines, hauling freight across the continent, these costs made sense. But branch lines, the capillaries connecting small towns to the railroad network, were hemorrhaging money. Consider the math. A steam locomotive and tender weighed roughly 400 tons. Add passenger coaches, a baggage car, a mail car, and the required crew, and you were burning through coal and wages to move perhaps 30 passengers. On rural routes, where a dozen people might board on a good day, every trip was a financial catastrophe. Union Pacific's solution had been simple: abandon communities, let the branch lines rot, let the small towns wither. But Edward H. Harriman, the railroad titan who controlled 60,000 miles of track by the time of his death, had a different vision. Harriman had clawed Union Pacific out of bankruptcy in 1898, transforming it into one of America's most profitable operations. He believed there was money in those branch lines, if someone could crack the problem of cost. He turned to a 34-year-old mechanical engineer named William Riley McKeen, Jr. McKeen was Union Pacific's superintendent of motive power and machinery, the man responsible for every locomotive in Harriman's Western Empire. He was dapper, meticulous, and impossibly stubborn. According to one mechanic who worked with him for years, if a worker suggested an improvement to his designs, McKeen would simply whistle, blow Turkish cigarette smoke through his full beard, and walk away. In 1904, Harriman gave McKeen $385,000, over $10 million in today's currency, and a single instruction: build something that could carry passengers without bleeding the company dry. McKeen's answer would horrify everyone who saw it. That same year, the 1904 World's Fair opened in St. Louis. Nearly 20 million visitors wandered through 1,200 acres of exhibition halls, showcasing the future, X-ray machines, electric lighting, and automobiles from 29 manufacturers. But McKeen was drawn to a different display entirely: German research on aerodynamic design, and he was especially focused on aerodynamic ideas. The Germans had been testing wind resistance on high-speed vehicles. Their data showed that a pointed nose and rounded tail could reduce air drag by 75%. McKeen noticed something else. The optimal shape looked exactly like a ship's hull. The idea struck him like a revelation. What if a railroad car could be built like a boat, pointed at the front to slice through the air, and rounded at the back to prevent the vacuum that dragged on square-ended coaches? McKeen returned to Omaha and began building. In March 1905, Workers in the Union Pacific shops watched something strange emerge: forgings, machined parts, and what appeared to be an inverted boat from the car shop. A boxcar arrived carrying a 100-horsepower gasoline engine built by Standard Motor Works of Jersey City. When the pieces came together, the men saw a vehicle unlike anything that had ever run on rails. It was 31 feet long, painted deep maroon, with a knife-edge nose that came to a sharp steel point. The design was not decorative. McKeen had calculated that a flat-fronted train car required 87.5 horsepower just to overcome air resistance. His pointed design needed only 21.9. He had cut the drag by 3/4, exactly as the German data predicted. The car ran on gasoline instead of coal. It required a single operator instead of a full train crew. It weighed 30 tons instead of 400. The economics were revolutionary. McKeen cars achieved roughly 2.4 miles per gallon, remarkable efficiency for a 30-ton vehicle, better than modern military tanks weighing twice as much. But nobody was talking about economics. They were staring at that nose. Safety officials looked at the steel prow and imagined collisions. The blade would punch straight through whatever it struck. If another train hit the McKeen car head-on, critics argued that knife edge would drive backward through the passenger compartment like a guillotine. Newspapers mocked it. Labor unions feared it would eliminate jobs. Competing manufacturers lobbied against approval. One nickname stuck: the suicide sled. McKeen's response was characteristic. He said nothing. He simply kept building. By 1908, the McKeen Motor Car Company had formally incorporated as a Union Pacific subsidiary. Orders were arriving from railroads across the country. But the fear never subsided. The concerns were not irrational. In 1906, a Baltimore and Ohio locomotive running at full speed had plowed into a passenger train at Terracotta Station in Washington, D.C., telescoping the rear cars and killing 53 passengers. In 1904, a Southern Railway collision near New Market, Tennessee, had caused both locomotive boilers to explode while the wooden passenger cars crushed together like accordions. These were not rare events. They were the ordinary cost of riding American trains. Against this backdrop, the McKeen car looked like a murder weapon with wheels. The porthole windows, circular openings that McKeen and Harriman actually patented for land use, added to the sinister appearance. The design was nautical, submarine-like. Passengers stepping aboard reported feeling like they were entering a torpedo. Critics focused obsessively on that pointed nose. In a collision, they predicted, the blade would become a spear. The passengers seated behind the engine compartment would be impaled or crushed as the steel prow drove backward into the cabin. McKeen addressed none of these concerns publicly. Instead, he pointed to something else: the all-steel construction. While conventional passenger cars of the era were built with wooden bodies that splintered and telescoped during crashes, McKeen's cars used a monocoque steel design. The body itself was the frame, like an aircraft fuselage. The steel walls resisted crushing. The center door entrance, located midway down the car, rather than at the vulnerable ends, meant passengers could evacuate even if the nose or tail was damaged. And the absence of a boiler eliminated the most common source of railroad fatalities entirely. There was no superheated water waiting to explode. No crown sheet to fail when water levels dropped. No risk of being scalded to death by escaping steam. But nobody wanted to hear about steel walls or missing boilers. They wanted to know about that knife. The cars entered service anyway. Union Pacific put them on branch lines in Nebraska and Kansas. Southern Pacific deployed them in California and Oregon. The Virginia and Truckee Railway in Nevada ordered a 70-foot model to connect Carson City with the mining towns to the south. Ordinary people, farmers, shopkeepers, miners, and their families began climbing aboard the death machine. And then they stopped dying. On the St. Joseph and Grand Island Railroad in Nebraska, two McKeen cars collided head-on at a combined speed of 75 to 80 miles per hour. The impact happened on a sharp curve. Both cars were fully loaded with passengers. The result should have been catastrophic. By every prediction of the critics, the knife-nosed fronts should have driven through both passenger compartments, killing everyone aboard. Instead, the all-steel construction absorbed the impact. The first 7 to 10 feet of each car crumpled like designed crush zones in a modern automobile. Both cars stayed on the track. Every wheel remained on the rail. The passengers were thrown from their seats, windows shattered, and the damage was severe. But not one bone was broken. Not a single passenger died. One man who survived later recounted sitting near the back of the car when the collision occurred. When the dust settled, he found himself under a seat toward the front, thrown the entire length of the car by the impact, yet he walked away. The McKeen Historical Society has documented the accident in detail, reporting that no passenger or engineer suffered a broken bone, and that every wheel remained on the rails. Across the country, the pattern repeated. McKeen cars derailed less often than steam trains because they were lighter and had a lower center of mass. When they did crash, the steel construction prevented the telescoping that turned wooden cars into coffins. And the absence of a boiler meant that even a catastrophic collision could not produce the secondary explosion that turned so many steam accidents into infernos. The Virginia and Truckee's McKeen car entered service in June 1910. It would run continuously for 35 years, accumulating nearly 500,000 miles of service before being retired in 1945, one of the last unmodified McKeen cars still operating in America. In all that time, across all those miles, carrying countless passengers through Nevada's mountains and valleys, the documented passenger fatalities attributed to the design were zero. Evidence accumulated in railroad accident reports, Interstate Commerce Commission statistics, and insurance records. Steam railroading remained one of the deadliest industries in America. But the gasoline motor cars, the machines everyone had feared, kept their passengers alive. The knife never killed anyone. If the McKeen car was so safe, why did it disappear? Between 1905 and 1917, the McKeen Motor Car Company built exactly 152 vehicles. By the early 1940s, the last mechanical McKeen cars were being retired from Union Pacific service. Today, only a handful of bodies survive. The Nevada State Railroad Museum in Carson City preserves the lone operational McKeen car, Virginia and Truckee number 22, fully restored in 2010 and designated a National Historic Landmark in 2012. The McKeen car did not fail because it was dangerous. It failed because it was early. The gasoline engines were underpowered for their task. A 200 horsepower motor driving a 30-ton car was undersized at best, as one contemporary observer noted. The mechanical transmission, borrowed from marine engineering, was brutal on railroad service, and vibration and rough handling caused constant breakdowns. There was no reverse gear. To back up, the operator had to stop the engine, shift the camshaft to a different set of cams, and restart in the opposite direction. Railroad crews hated this. Starting the engine required compressed air from the car's reservoirs. If the air ran out, the McKeen had to be pushed or towed, and there are documented cases of crews using horses to get their motor cars moving. Maintenance practices of the era simply could not keep pace with the technology. Railroads that expected their equipment to run with minimal attention found the McKeen cars demanding constant work. And then Edward Harriman died in 1909, and with him went the McKeen car's most powerful patron. His successors at Union Pacific were less enthusiastic. Orders slowed. By 1915, only 2 cars were built. Production ended entirely in 1917, with Union Pacific absorbing the company's assets in 1920. William McKeen retired to Santa Barbara, California, around 1923. He died in October 1946, mostly forgotten after a long illness. He was 77 years old. Within 20 years of his death, diesel-electric locomotives, using the same internal combustion principles McKeen had pioneered, had conquered American railroading entirely. Steam was dead. The future McKeen had glimpsed became the present. But by then, the McKeen car was already a curiosity, remembered, when remembered at all, as that dangerous-looking machine with the knife nose. History has a cruel sense of irony. The machine that looked like death incarnate saved lives, while the steam locomotives everyone trusted kept killing. The knife that never cut anyone was condemned as a murder weapon, while collapsing wooden cars and exploding boilers were accepted as the cost of progress. William McKeen understood something his critics refused to see. Safety is not determined by appearance. A pointed nose that inspires fear may be safer than a flat front that inspires confidence. An all-steel body that looks industrial may protect passengers better than a wooden car with elegant mahogany trim. We face the same blind spot today. Autonomous vehicles are judged by how alien they look, not by their actual safety records. Artificial intelligence systems are condemned for capabilities we can see, while we ignore risks from technologies we have grown comfortable with. We confuse the familiar with the safe and the unfamiliar with the dangerous. The McKeen Motor Car was born 30 years too soon. Its engineer was dismissed as reckless. Its design was mocked as suicidal. Its safety record was ignored in favor of speculation about what might happen. What might happen never did. The next time you encounter a technology that looks wrong, that triggers an instinctive fear, that defies expectations, that seems designed by someone who does not understand human nature, ask yourself a simple question. What if they are right and everyone else is wrong? The suicide sled ran for 40 years without killing a single passenger. History remembers it as a failure,